we're speaking about design patterns and so forth, user interface design and the other design stuff. And then we are now speaking mainly about construction, which is implementation issues. Okay, and in implementation, right, as I said before, you're going to speak about mainly, of course, coding. So you write programs, but of course we don't teach coding per se in the course, because coding or programming is a course or many, you take at least 2 courses, right? So there are many courses you take for programming, so that's part of it. So coding, you know, in general what it means. So you select a programming language based on the paradigm you have decided, and then you start writing your program. So that's part of it. But apart from coding, we also do debugging and some testing, right, to make sure our code is working. So we'll see later that testing itself has many levels of testing, but at least as a as a start, once we do our program, we write our classes, we want to test the classes, and that's called unit testing. So there are many testing, but at least the unit testing is the one which is directly related to the programmer, what he has to do, right, or what he does. So now, although we are not going to speak about coding, we are going to speak about some of the issues related around coding and debugging, right? So one of the things as a programmer, as a coder, we have to keep in mind is that once we write our program, we want to make our program, there are a few things to keep in mind. My code should be neat and understandable, right? Right? So that's very important. What else are some of the goals of a programmer per se? Can you think about some ideas? Yeah, so we want to make it short and simple. In a sense, yeah, short means, yeah, simplicity is important. So use simple. What else? What are my other goals as a programmer? Of course, I have to write, yeah. So I have to write my code, which is, yeah, which is working. So naturally, it does satisfy the functionality. That's true. The question is, yeah, I have to also write my code, which is reusable. And that's true as well. And so we have to satisfy the quality attributes. And many of those quality attributes are coming from design, right? So normally we are speaking about reusable code or flexible code. So it should be in the design itself. So my class diagram should be designed in a way so that my code is reusable. You see my point? So most of these are, yeah, it's true that it should satisfy, for example, my code should be reusable, or it should be flexible and stuff like that. But what I'm saying is that many of these quality attributes are directly coming from design. So we don't have to do a lot rethinking about how to structure my code to make it reusable. It should come from design. So again, the question is also, there's a comment mentioned here is that we should avoid excessive inheritance. Now, the point here I'm trying to make is that once you're writing the code, what is your input? What is the input for the programmer to write his code? Let's think about that. So my question is, what is the input artifact for coding or implementation? Tell me, what do you think? What is the input artifact for coding? If I'm going to write my code, what is the input for me? Any answer? Who can tell me some answers? Anyone has anything to say? Or shall I use call the names from the participants who can give me some answers? Is a requirement document my direct artifact which I use to write my code? Is this true? What is the most direct artifact I need to write my code? Design document, right? So basically, yes, you're right. So most important document or artifact, of course, as a programmer, you might refer to requirements document. That's true. But as a programmer, the most important thing is your design document. So my question is now, avoiding excessive inheritance. This should have been dealt with already in the design document, right? In your class diagram. So as a coder, you look at the class diagram and you're trying to implement it. You're not going to redesign your classes. So you're not going to address that issue. Oh, maybe I should make some inheritance more or less. I should reduce some inheritance or things like that. You're basically implementing the design, and design in your class diagram, it's already available, right? So yeah, it's true that we have to look at the quality attributes, right? Like reusability, flexibility, and stuff. But keep in mind, these are already, or this should ideally be already there in the design document, these type of issues. But for example, making my code simple is not directly explicitly in design. I have, once I'm writing my code, the use of variables, which variables I use, or how I indent my code, and stuff like that is not in design. It's my choice, right? So I have to make my code neat and understandable. I have to make it simple in that sense also, right? So these are my decisions, and I have to make these decisions, right? Similarly, following coding standards. And of course, if you follow coding standards, most of the time you are also satisfying some of these goals, right? But not that's not the only thing. So it means what I'm trying to say is, in order to make your code neat and understandable or simple in that sense, following coding standard helps, but that's not the only thing. You can do more, right? Yes, please.
Make my code simple. Is it simple to read or simple to understand?
Yeah, I understand the comment which was mentioned in the chat. The simple, again, correct me if I'm wrong. The simple is the idea that it's simple to read and understand. This was what I understand once it was mentioned in the chat. So of course it's related, right? These are not two independent things. So if you have neat and understandable, how to make it understandable is also to make it simple.
But sometimes the code be complicated. But so how can I make it simple?
Yeah, that's the point here. So you should try to make your code as simple as possible. That's the general idea here, right? So don't put things together. For example, just one thing, very quick example here. So I can do this in example in Java. So I can say sum plus equals to a of I semicolon. Let's say, I'm sorry here, I plus plus and semicolon. I can put this in one line, right? In my Java editor. Can I do yes or no?
Yes.
Yes, but maybe a better idea would be that I just split them into two, because these are two different instructions. So I say sum plus equals to whatever was there, a of I, and then I say here I plus plus. So it makes it more understandable, more clear, right? This is a very simple example, but my point is these are our choice as programmers, how I put my code, right?
Yes, it's right.
Yeah. So this is one thing. So following coding standards are important, and we'll see some ideas here, and also code comments and documentation, coding documentation. So these are also important aspects, right? So we have to make sure that once we write the code, we provide proper comments and documentations. So is there anything, there's a comment here that I can't see the the writing. Is it visible to all of you or no? Let me know what I'm writing.
Yes, it is visible.
It's there, right? You can see the whiteboard.
Yeah.
Yes, good. Okay. So yeah, what I said is, as a design, as an implementer, as a coder, of course you need to follow the design document, right? So you should not be redesigning your classes. You should not be redesigning the methods. The design of is there. But what you are looking at is you're going to implement that design. And while implementing, you make sure that your code is simple, you're neat and understandable, you follow coding standards, you do comments and documentation. Apart from once you write your code, you have to debug and you do unit testing to make sure it's working, right? So these are some of the issues of software construction, which you should be careful about. I hope this makes sense, right? And of course, by doing this also, you make sure that you don't make your code complex, make your code simple and easy to understand, right? So we should also try to manage complexity. So again, question now would be that what are the so what is something important for us to understand is these two aspects: following coding standards and coding comments and documentation. These are important aspects to keep in mind. So now, if you speak about, for example, coding standards, anyone who can give me some answer, what do we mean by coding standards? Anyone who is aware about some coding standards?
It's about tabs and space between the lines and something like that.
Yeah, so the point here is every programming language has some standards of how you should do coding. Okay. So for example, Java has some coding standards, C language has its own coding standards, C++ has its own coding standards and stuff like that, right? So you should follow, once you're looking at a language, you're using a language for implementation, you should follow some of the coding standards of the language. So for example, how should you name a variable in Java? A variable name should start with a capital letter or a small letter. Small letter, right? Small, yeah. And the thing is, if you have multiple names in a variable, for example, number of days, so you start with a small letter and then say, so each word starts with each other word starts with a capital letter. So these are standards, right? Which should be followed. So these are examples. So naming standards is one important thing to keep in mind, right? So how do you name a variable? How do you name a method? The class name. How do you name a class? So we are speaking about coding standards. One category of them is naming standards. So we speak about, for example, this was just an example here. So we are speaking about naming variables, naming methods, naming classes, right? So we spoke before in different occasions, for example, of naming methods. Anyone who can give me some quick idea, what are some of these example standards of naming a method? Some standards of naming a method? So let me write here. Some of the examples of naming a variable is, it's a noun and starts with lowercase. And as we spoke about, there are other things like if you have multiple words, then every other word starts, the first letter starts with a capital letter, right? What about method? We said the name should be, generally speaking, verb. And again, it also starts with lowercase. And if you have multiple words in this thing, so get name, so you say get G is, so example of that is get is small, but name is capital and stuff like that. Now, what about naming classes? What are some of the common standards for naming classes?
Should be all capital.
All capital, or it should start with capital. So it should be, again, classes are again noun, and normally again it is singular. So you don't say students, you say student, and then the first letter, so it starts with uppercase, and the other standards also, right? So you speak about student, right? This is a class, as an example, right? So here now, is there any other thing you need to be careful about naming? Is there anything else? What about file naming? So you should also be careful about naming your files, right?
Avoid some names like class. You can't name your file class.
Yeah, of course, there's things you can't do it, but things you can do it, you should have proper naming for those classes, right? Your codes, your program files should have proper names. Your documentation should have proper names. Your manuals should have proper names. So every file you're creating should be properly named. So this is also part of the thing you should be concerned about, right? So just think about that. How does a coding standard help? Just as an example, let's take this example. I have in Java system dot out dot println, right? You use this many times in Java. Now, who can look at the coding standard and try to decipher what exactly are the elements here? What are the things here? Which one? Of course, for example, one obvious thing here is that println is a method, right? Is this true or no? Println is a method. But what about the other parts? How can you know what is system, what is out? Give me some ideas here. We understand println is a method. It does something. But what about system? What about out?
System may be a class because start with the upper letter.
Yeah. So this is yes. This is one idea. Other ideas: system and out. What about out? Package and class. Not really. We'll see more. Any other idea? What is system? What is out? If system is a class, what is out then?
Maybe variable.
Maybe a variable. So you say variable dot println, or what do we mean by variable? Think about it and let me know. Object. So it seems, yeah, it should be object, right? Why we understand that this should be an object? So as someone said, system looks to be a class. Why? Because it's a uppercase, the starting word. And println, we know for sure this is a method. So what about this one? So it seems that this is linked to some method. So this could be some sort of object. And objects are, the name of an object inside a class should be a small letter. So basically, what does this tell us? It tells us that what is the nature of this OUT? It's an object which is static or non-static. What do you think? It's static, right? Why? Because you're using from the context of the class. So you're saying system, which is a class, which is a capital, it starts with an uppercase. So system is a class, but you're saying class dot some object. It means you're using class variables, the static objects. So out is an object of another class which has a method called println, and this object is defined in a static context, and that's why you are using the class name dot object dot println. Is this getting clear? So this is just an example how you can understand the details, internal details, if you follow a standard. But if, let's say, someone decided that no, I'm not going to follow the standard for naming, and I for some reason named the system as small, lowercase system, and then I said object as uppercase, and then something like println. What do you think? It will be very difficult to understand, right? What's going on inside it. You see my point? So, oh, this is, what is it? Is it a class, object? And again, this is a class object or class. It's not easy. But as long as you follow the standards, you can understand what's going on. Is this clear? So naming is very important. So you should be careful about how you name your variables, your methods, your classes, and in general, whatever you're naming, you have to be careful about that. Right? So naming, as I said before, again, is very important to keep in mind. Similarly, there are other important things. So also, this was the idea that the naming of the instance variables. But what about even naming the local variables? So the naming of the local variables, right? You should follow proper naming, right? So for example, let's not use a equals to 10, b equals to 50 times a, and stuff like that. These a, b's should ideally be replaced by proper names. What is a here? For example, this could be discount rate. So you're saying discount rate or something like a scale. I don't know, whatever it could be. So you're saying scale equals to 10, and this is saying the new dimension equals to, for example, 50 times scale. I don't know. I'm just giving some example. So again, the variable names are also very important, the local variables inside a method. So anything you're naming, you should be careful about how you name it. Give proper meaningful names. Okay. What else do we have? So what about white spaces? So white space is also very important. So shall we use like this? Right? Sum equals to sum plus a, or for example, we should say instead of that, sum equals to sum plus a. So you should have some, there are standards. It says, for example, once you have operators, you have space between them, right? You should have space between them. So stuff like that. So you should be careful about spacing, even in indentation and spacing. So for example, if you have a loop, right? So let me, yeah. So if you're writing a loop for, right? You have some things. So you should have the opening bracket here after a space, and where should be the closing bracket? In the same indentation wherever you are going to end it, right? And then anything inside it should also be indented. Something, and this tab indentation is there, this space is there, right? So which tells you this spacing is there. So white spaces and indentations, very important, right? Then what about blank lines? Anything you can think about blank lines? Where do you give these empty lines? So if you have a long set of instructions, right? So examples of that would be, let's say you are going to do this variable initializations, variable declaration and initialization here. Variable declaration and initialization. So once you have done this, Now the other parts, maybe you should give a space here. A one line space and then start other logic. And maybe you are doing something and then you need a loop. Give a space and have a loop. Once you finish a loop, give a space to add other logic code. So your blocks of code which have some common purpose, you're doing it together, should be separated by other blocks in the same file or the same method by some spaces in between. Similarly, between methods, you should have a space, right? So if you have a class name, so you say class student space this, right? And then you have a method. So you say, again, I'm just making it short, get name is there. Now, once this method is ending, you have a space to start another one. Get contact and so forth. So these are spaces. You should be careful about these empty lines, blank lines in between and so forth. If you have variables inside the student, so for example, you have what private name is, so you have name as a variable, you have age and stuff like that. Then after these instance variables, you have a space before you, a blank line before you start a method. So these are some of the things you should be careful about to make your code more easy to read and understand and stuff like that. Now the question is why in general, again, so we understand that following coding standards, and we should be aware. So you can easily access, for example, Java coding standard guidelines, right? Is there available, and you can go through it to make sure that you're following most of the standards. So now the question is why, and we understand that following coding standards make your code easy to understand and read, apart from other things like adding comments, documentation, and stuff like that. The question I'm asking now is why generally our code should be easy to read and understand? General question. What do you think?
To find an issue or a problem or bugs easily.
Yeah, this is one very important reason. So if I have some bugs or issues in my code, it's sometimes it's very cumbersome. It's taking a time-taking activity to locate your bugs. But if you follow your standards and your code is easy to read and understand, there's a high chance that you're going to locate your bug easily. Right? It's also beneficial to help your reuse your code. Of course, if you understand your code, you're going to reuse it, right? What else?
And if it's open source, it's easy to everyone to understand and add to it or fix it.
Yeah, and even think about it. If it's not open source, you write your code. I'm not sure how many of you have experienced it. If you look at your code after a few weeks or if not few months, you might sometimes start wondering, why did I use this statement? Why did I do this thing? What was the logic behind this? So again, if you don't write your code neatly, following standards, so that is easily understandable, even you who wrote your own code, if you visit your own code after some time, you might just it won't be that easy for you to follow. So very important, right, to make your code understandable. And many a times what happens, we work on a code and we deploy the code, we give it to the client, and someone else is going to maintain the software. So many a times the person who's going to update or maintain the software is not the same person who wrote the code in the first place. So imagine he is not even the author of the code. So for him to understand your code is a very difficult job actually. It's a very challenging thing. So if you don't make your code easy and simple to read and follow, it's going to be very difficult for others to maintain the code. So we have to be careful about that, right? Good. So what else are important things? For example, even in the naming, let's say the I's and J's. In Java generally, where do I normally use I's and J's as variable names?
In loops?
Yeah, as indexes and loops, right? So that's okay. So we are not saying that every time your names should be like sum and average or big names. Of course, it should be where there's a meaning. But many times, even small names and like I's and J's are acceptable. And especially they are acceptable once you're using as index of array or loop variable. So for I equals to 0, I less than 10, that's okay to use. And actually, it's even encouraged to use that way because that's how people associate these names with I's and J's and stuff like that. You see? Okay, what about if a variable is a constant, such that it does not change its value. How do you define a constant in Java?
Final.
Final, the keyword final, right? So if you have a final variable, how should you name that variable?
Capitalized.
Capitalize. Yeah, so that's another thing. Again, these are standards and guidelines. If you don't follow, it's okay. But again, we are saying we should follow ideally, right? So again, this is one more thing is that our constants, which are final in Java, should be caps lock, all capital, all capital. But what if you have a constant which has multiple words? Then what do you do? Because if you put everything all caps,
And use underscore.
use underscore. Very good. So for example, you have a constant called name of, I don't know, something, name of batch, and you give a value, something is that. So this is a constant which has multiple words, so you separate them by underscore. So these are also important things to keep in mind, okay? What else do we have as important things to keep in mind? So yeah. What about comments? Yeah, so let's now move to comments. So we are now speaking about code, documentation, and comments. Again, very important aspect. We should make sure that I document and use comments. So as we mentioned before, somewhere, some other place, we have two types of comments in my Java code, for example. One of them are called code comments. And the other one is called the comments for documentation. Documentation comments. Now, what are code comments? When do we use code comments? Or what is the reason of using code comments? Again, code comments in Java at least. Yeah, you explain. So you have something like you have block comment, which is * ending by this, or you have the line comment, right? /. These are examples of code comments in Java. So the question, yeah, this is how you do it. But what are the benefits or what is the reason of commenting code?
To explain the code.
Yeah, to explain the code, and this explanation is for whom?
For the maybe who will use the code, or for the client, or for some user.
Yeah. One of the things is for myself, as we just said, that I might look at my code after some time and it's not easy for me to follow what I did maybe 6 months back. So having comments in the code will help me understand the logic of the code. So understandability, it increases naturally the understandability of the code. So it's for the one who wrote it also, but also for those of those who are interested to reuse my code, not as a library, but who has access to the code, right? Someone else who's going to maintain the code, someone else who's going to use this code, and he has access to the code, not just as a library, but as a code. So he needs those comments, right, to follow it. So if I'm maintaining the code, I need to understand what was the logic so that I can make changes to it. Or for example, code comments also help me in debugging, as we just said, because it increases the understandability of the code. So it helps in debugging and stuff like that. Now, what about the documentation comments? What is documentation comments? Who and for whom it is?
For stakeholders?
It's for those who are going to use my code, reuse my code as a library. So who does not have access to the code necessarily, but who has to use this code as an API just by calling the method. He's not going to make changes to the code itself, but just reuse the code as an API. So you know, for example, there is something called Java doc. So this is an example of Java documentation comments. Java doc, right? So you're speaking about, and how do we do Java documentation in Java? So we have */. and it ends with /star. So these are Java documentation comments. So you see, if you compile your code and you run your Javadoc tool, it looks for those comments which starts with /$, and it knows these are documentation comments. And using these, it will extract these documentation comments and make an API documentation for you automatically. So there's a comment here, do comments decrease the efficiency, the runtime efficiency of the code? What do you think? The answer, which is already mentioned here by Hussein, is no, right? So actually comments, you write any number of comments, it does not change your runtime efficiency, because once you convert your code to your class file, your bytecode, all those comments are stripped off, right? So comment does not change. It does not, because it's not part of the instruction. It ignores the comment, exactly. So it does not affect the efficiency of the code. So in Java, in Java, for example, if you want to do documentation comment, you use these things, /$, and then you also have some of the tags. You also make use of tags like @. These are also special things for Java documentation. @. So let me give you an example here to make it clear what we mean by Java documentation, right? So let's look at this one. Let me share with you. So can you see this documentation? I hope it's visible to you. Yes, no?
Yes.
Yeah. So what do we see here? Let's look at this code. We have star, so we have /$. So which is telling that what comes right till this. All of this is what? Is documentation.
Doctor,
Is Java, yeah.
should I put star in each line?
No, that's not needed, but it's a general standard. People do follow it, and many of the editors, if you put star like this and put a new line, it will automatically put stars for you, just for readability. But it's not mandatory to do it. So you see what it does. Now, once you run Javadoc, it will extract this part as Javadoc comment. So this is not the normal code comment which you have with these block comments and the line comment. This is special Javadoc comment. So what this is there? What is this? This is explaining, actually all this comment is explaining this method. So normally you put comments before a class starts, before each method and before each instance variable, for example, the minimum. So you explain your class, you explain your methods, and you explain your instance variables, right? So then the question here is this method. So what does it say? If you see all of this, this will basically be extracted, and this is the explanation you will find for the method, which is the method getImage. Then there are special tags with @, and one of the tag is called @param, means @parameter. What is the parameter you have here? URL. So you see it says URL, and then you give an explanation what this parameter is. So an absolute URL giving the base location of the image. You have another parameter, name. So you say @parameter name. So it says then what is it? The location of the image relative to the URL argument. So these are explaining the parameters by @param. So you have @parameter. Similarly, this method returns back an object of type image. So you say there's another tag called @return, and you say what's returning? The image at the specific URL. And because this method is returning an object of another class, so you might say, for example, @C, which is again a special tag, image. And if you have this image as a class, so naturally you're expecting that image class also has a comment, Javadoc comment. So what it will do is once the Javadoc tool, if you run the Javadoc tool over this file, it will extract and put a URL, a link to the code comments for the image class and so forth. So let's say you run Javadoc over this, what will you get? You expect to get something like this. You see automatically a Javadoc file where you see this. So you have a URL image So it says, if you remember, this was the block comment you added for the method. It explains this method, what does it do? And then it puts this special keywords, parameters, URL, name, and you explains the thing. Returns, what does it return? C also image. You remember @C? So if you click this, it will open the code documentation for the image class and stuff like that. So again, what are the things we should create Java doc for? Mainly, we should create Java doc for every public method, if they're a public instance variable, and of course for every class. Very important, right? So again, I'm repeating, we have two types of documentation. The comments in my Java code. We have comments for the author of the code, for understanding the code later on to make maintenance, do maintenance, or to do debugging and stuff like that, or for others who are going to use my code in their project, or they are going to maintain my code. So those are code comments, which explains the algorithm inside the method, anything inside the in my code. But there is another one which is code Java documentation comment, which is for those who are going to not necessarily access the code, but going to use the class or the methods as the API. So we want to create Java doc file for them. Is this clear what I'm saying?
Yes, doctor.
Yeah. So again, the main point, just to wrap up the discussion for today, the main point what we discussed today is that while we are writing the code, right, we don't have to, of course, our code should follow good designs, but we don't redesign the design itself. So our class diagram is there. We don't redesign it. Of course, if you believe that there are things which needs improvement, we go back and improve the design first. But once my design is there, that's the most important artifact for my implementation. I follow my design exactly. But then what I have to be careful about is once I write the code, I should follow the documentation standards, right? I should and the coding standard. So I should use proper names, spaces, indentation, parentheses, all those stuff we should be careful about. And not only that, then I should also be careful that I add proper comments in the code. And comments themselves could be comments related to the code comments or documentation comments. So we have to be careful. As an implementation guy, we have to be careful about these aspects. So is there